In this video, we are going to talk about homogeneous first order differential equations. How to obtain the general solution of a homogeneous first order differential equation. Alright, let's go ahead. I'm going to use these two examples to show you how to solve a homogeneous differential equation. So watch the video to the end and see how it's going to be done. Let's go with the first question. We are going to solve the differential equation dy dx equal to y minus x over y plus x. What we are going to do here is this. We are going to make a y equal to vx substitution so as to reduce this equation to a variable separable differential equation. That is the goal. So this is what I'm saying. Let y be equal to vx. Yes. So we will differentiate y with respect to x, dy dx. This is a product, so we apply the product rule. Okay, the product rule, dy dx equal to u dv dx plus v du dx. Let's take v as u, okay, and let's take x as v. So going by the product rule, let's write down v, then differentiate x with respect to x, that's dx ds, plus we'll write down x now, and differentiate v with respect to x, and that's what? Dv dx. Dx ds is 1. So dy dx is equal to v plus x dv dx. So what we are going to do now is this. In place of y, we are going to write vx, and in place of dy dx, we'll write everything here. So that this will now become v plus x dv dx equal to y, which is now what? Vx minus x upon y, which is vx, then plus x. Okay. So from here now, I can actually factorize x out. I can factor x out. So I can say x will come out, we have v minus 1 divided by x will come out, we have what? V plus 1. So if x cancels x, we are left with v plus x dv dx equal to v minus 1 upon v plus 1. Alright, let's try to see if we can separate the variables. Of course, we can do it, but let's work it out. Let's take v to the other side. So we'll be having x dv dx equal to v minus 1, alright, all over v plus 1 minus v. So if we simplify this, we are going to obtain v minus 1. Okay, by the LCM shortcut, I want to multiply v plus 1 by minus v. That's minus v into v plus 1. Then divide everything by v plus 1. You get the point? So x dv dx will be equal to what? V minus 1. Then minus v will enter that bracket. We'll have minus v squared minus v. Alright? Divided by what? V plus 1. So v minus v is out. We are having what now? Minus 1 minus v squared minus 1 minus v squared, all divided by v plus 1. So x dv dx is equal to what? Minus 1 minus v squared upon v plus 1. Of course, I can see this is equal to what? Minus into 1 plus v squared all over v plus 1. So I'm working with this now. Okay, let me erase this. Okay. So we now have this x dv dx equal to minus into 1 plus v squared, all divided by what? V plus 1. Alright, let's go ahead. I want to cross multiply. Remember, we are trying to separate the variables. So we'll be having x into v plus 1 dv, okay, is equal to what? Minus 1 plus v squared dx. This is what we obtain by cross multiplying. What we are doing is the terms in v and dv should be alone on one side, and the terms in x and dx should be alone on the other side. So if that's the target, it means that if we are leaving the v and v on the left hand side, we are going to take x to the right hand side. And of course, this particular term here will come to the what? The left hand side. So this is what we are going to do. To remove x from here, we are going to divide both sides by x. And to remove 1 plus b squared here, we are going to divide both sides by 1 plus b squared. We can leave the minus alone, okay? So this is what will happen. We'll be having v plus 1 all over 1 plus v squared dv equal to minus dx divided by what? X. This is what we have. We have totally separated the variables. So we'll have to integrate both sides now, all right? Let's do the integral of both sides. We can write this as minus the integral of 1 over x dx. Good. So that it will be easy for us to understand, all right? And actually, if we integrate 1 over x dx, it's going to produce ln x. Okay, we have a minus here. So that will be minus ln x plus c, which is the arbitrary constant. Okay, and how do we integrate this now? The integral of v plus 1 over 1 plus b squared dv. We are going to split this integral. We are going to split it to obtain the integral of v over 1 plus v squared dv plus the integral of 1 over 1 plus b squared dv also, to make it easy for us to what? Integrate. Because if we evaluate this now, v over 1 plus b squared plus 1 over 1 plus b squared, we are going to obtain this expression here. It's the same thing. Let us integrate this left hand side now. Look at this very well. Let's start with this. The integral of 1 over 1 plus b squared dv. What is it equal to? It's straightforward. Look at it. The standard integral says that the integral of 1 over 1 plus s squared dx is equal to the tan inverse of x, all right, plus the arbitrary constant c. So basically, it is the tan inverse of x. How do we integrate v over 1 plus b squared dv? If I look at the denominator, I have 1 plus b squared. And if I differentiate 1 plus b squared with respect to v, I will obtain 2v. But I'm having v at the numerator, so I can actually make that numerator contain 2v by doing something like this. I'll multiply both up and down by 2. That's the integral of 2v, all right, all over 2 into 1 plus b squared dv. It's the same thing. But I want to remove this 2 and bring it outside as 1 over 2. I'm still correct. Then I have this. What is the integral of 1 over 1 plus b squared dv? It is actually the tan inverse of v. Yes, that's what it is. Then we have equal to minus ln x plus c. So this one, since the derivative of 1 plus b squared dv is 2v, that means this integral will now be equal to, we have half into ln the natural logarithm of 1 plus b squared plus the tan inverse of v equal to minus ln x plus c. So having gotten this, we have to make back that substitution, okay, to get the general solution. You know, the equation we are given is, this is it, in terms of x and y. But here it is in terms of x and v. So remember we said that let y be equal to what? Dx. Remember that we said that earlier. So from here now, if y is equal to dx, divide both sides by x, so that y over x will be equal to v. v is equal to y over x. So we are going to write y over x now for v in this solution. So this is it. 1/2 into 1 plus, this is v squared. So we'll be having y squared over x squared. You get the point? Plus the tan inverse of v, which is y over x, equal to minus ln x plus c. This is the general solution of this particular differential equation. I'm going to solve the second example. Okay, so I will explain, I will buttress the points once again. Keep watching. Here is the second example. Let's go ahead. This one is an initial value problem. IVP, initial value problem, because it has initial conditions. Okay, so solving an initial value problem will result in a particular solution. What we solved earlier was not an initial value problem. Okay, so we got a general solution. Here we are going to obtain a particular solution. Watch. dy dx equal to x squared plus y squared over xy. So the first thing is to make the substitution. Let y be equal to what? Vx. And if this is so, based on what we did earlier, we said dy dx is v plus x dv dx. Okay. So in place of dy dx now, we're going to write everything here. So we have v plus x dv dx equal to, in place of y, we write what? Vx. So this is x squared plus, we have vs all squared because of the squared in the y. All over x times y, that's x times vx. So we have v plus x dv dx equal to, we have x squared, and this will give us v squared x squared, v squared x squared upon, and this will give us x times vx, that's vx all squared. I can actually factor out x squared from both top and bottom. X squared into 1 plus v squared, right? That is it. All over, what's here? X squared v. So x squared take away x squared, we are left with what? 1 plus v squared all over v. So I'm working with this and this now. V plus x dv dx is equal to what? 1 plus v squared upon v. So the goal is to separate the variables x and v in this case. So v will cross and turn to minus. We have x dv dx equal to 1 plus v squared over v minus v. Let's simplify this. By LCM approach, we have 1 plus v squared, then this multiply this minus v times v, that's v squared, all divided by the v. So we're having what? V squared minus v squared is out. We have 1 over v. So x dv dx is equal to 1 over v. Now let's cross multiply. If we cross multiply, we are going to obtain x dv times v, which is x v dv, equal to 1 times dx, which is what? Dx. Right? And so we have, to separate it now, we have to divide both sides by x, so that x will go to this other side, and leaving v and dv alone on the left hand side. So x dv, okay, v dv is now equal to 1 over x dx. So at this point, we can now integrate both sides. To integrate both sides, we'll have this. The integral of v dv is v squared over 2. And we'll have the integral of 1 over x ds is what? In x plus c. Let's cross multiply now. V squared will be equal to what? 2 times everything here. That's 2 into ln x plus c. Remember that we said let y be equal to what? Vx. So from which v is equal to y over x. I did that earlier. So in place of v now, I want to write y over x. So we have y squared over x squared equal to 2 into ln x plus c. Okay, let's go ahead. We'll soon be done with the question. So we now have our solution in terms of y and x. The v is out. This is the general solution. Alright. Now we can now apply the initial conditions to the problem to obtain the particular solution. Y of 1 equal to 4 means that x is equal to 1 and y equal to 4. Or we can say when x is equal to 1, y is equal to what? 4. So let me put 1 here for x. Let me put 4 for y. So that we'll now solve for what? C. So we have 4 here. That will be 4 squared. 16. All over. Put 1 for x is still 1. So that one is out. 16 over 1 is 16. Equal to 2 into ln. X is 1. So put 1 here. Ln 1 plus what? C. Ln 1 is equal to 0. 16 is equal to 2 in bracket C, because this one is 0. Ln 1 or log 1 is 0. So divide both sides by 2. C is equal to what? 8. So the particular solution now to this differential equation is this. Y squared over x squared is equal to what? 2 into ln x plus, what is C now? 8. So we can actually cross multiply to obtain y squared equal to 2x squared into ln x plus 8. So this is the particular solution to this homogeneous differential equation of the first order. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like the video and share it with your friends and your classmates. I'll see you in the next one.